This is question 2. An estate agent recorded the price per square metre P, and the unit for this price per square metre is therefore pounds per metre squared, P, so that's the independent variable, for 7, 1, 2, 3, 4, 5, 6, 7 two-bedroom houses. He then coded the data using the coding Q. So to get Q, he's taken P, subtracted some number A, divided by some number B, which these A and B are both positive constants, and got this coded data. So part A asks you to find the value of A and B. So we could just try writing expressions for the coding for 2 of the 7 pairs of numbers in the table. We could say that, well, he's managed to get an answer of 4.0 out after taking this value of P of 1840, subtracting this number A that we don't know, and dividing by this number B that we don't know. Looking at the second pair of numbers, he's managed to get this coded number of 4.8 by taking the year 1848. The price per square metre, 1848, subtracting some number A and dividing by another number B. Now I could keep going, but this is enough information because we've got now 2 pairs of equations for our 2 unknowns. So what we can do now is solve these equations. One quite simple way to do that is to multiply both of them by B. So this now says 4.0B equals 1840 minus A. And from this equation, 4.8 times B equals 1848 minus A. With these 2 equations now, we could subtract them to make these 2 negative A's disappear. And I'm going to go for doing, let's call this equation 1 and equation 2. If I do line 2, take away line 1, then I could do 4.8b take away 4.0b, giving me 0.8b. And here, 1848, take off the 1840, leaves me with 8. And negative a, take away a negative a, will mean that we get 0. They will cancel out. So now I can divide both sides by 0.8, and b will be 10. Once I know b, I can find a by using either of these equations. So, for example, I could substitute b equals 10 into line 1, and so I would have, I'll include all my working out, 4.0 times by 10 has to equal 1840 take away a. So if I add the a over to this side and work out that this bit would be 40 and do 1840 take off the 40, I get 1800. And those are my values for A and B. Now it says, the estate agent also records the distance D of each house from the nearest train station, and the results are summarised below. So we've got information about SDD, so that's working with these distances, and then SQQ, so that's working with the coded house prices per square metre, and then we've got SDQ, which is to do with the relationship between them. And we're asked to calculate the product moment correlation coefficient between D and Q. So, this is part B. At this point, I would turn to my formula sheet where I've got information that says the product moment correlation coefficient is given by SXY over SXX SYY square rooted. Now in this case, we're not working with X and Y, we're working with D and Q. Now, it won't matter if you've got these the wrong way round, but it's worth noting that our x, or our independent variable, is going to be the distance of the house, d, and the responsive variable, I would imagine, is going to be what that means for the price per square metre. So that means our y is like our p. So that turns this formula into SDP. Sorry, we're using the coded one, Q. There we go. SDQ over the square root of SDD multiplied by SQQ. And now I can put the numbers in. SDQ is negative 2.17. SDD is 1.02. And we're multiplying that with SQQ, which is 8.22. Maybe I'll put a multiply sign so we don't muddle up with the decimal places. And then I can enter that carefully into the calculator. So I need a fraction. I've got negative 2.17. And at the bottom, I've got the square root of 1.02 multiplied with 8.22. And that gets me negative 0.74941, Now, it doesn't say how accurate to give it, so 3 significant figures would be the best thing to do. Negative 0.749 to 3 SF. Part C says, write down the value of the product moment correlation coefficient between D and P. Now it says write down, which means it should be a simple thing to do. And to answer this question, you need to know that coding does not affect the value of the product moment correlation coefficient. And so we can just simply write down that it will also be negative 0.749 for 1 mark. The estate agent records the price and size of 2 additional 2-bedroom houses, H and J. Suggest which house is most likely to be closer to a train station and justify your answer. So let's look at the information that we have. We know the price of the house and we know the size in meters squared. And we know that we have this product moment correlation coefficient, which is negative, which is telling us that, say if I drew a little sketch of this, it's telling us that as the distance from the train station increases, because we have negative correlation, the price per square metre of the house decreases. So we're getting a negative relationship, and because the value of R is minus 0.7, it's a fairly strong one, so the data might look something like this. So if I want to make a decision about which of these 2 houses, H and J, are likely to be closer to the train station, which are likely to be more in this direction, then I really want to know which of them has the highest price per metre squared, because according to our correlation coefficient, that's likely to be the closer ones. So I'm going to start with the house H, calculating the price per metre squared. So if I share the price of the house, 156,400, by how many metres squared there are in the house, so this is pounds divided by metres squared, then that will give me a value in pounds per metre squared. So I'm going to do 156,400 divided by 85. So that's giving me a value of 1,840 pounds per metre squared. Now if I do the same thing for house J, let's do it down here where I have a little bit more room. I'm going to take the price of the house, 172,900, and divide it by the 95 metres squared. To tell me that this house is 1,820 pounds per metre squared. So out of these 2 houses, it's house H that has the higher price per metre squared, so it's probably the one that's nearer to the station. So now I need to summarise that, so I could write does it say, let's look at the wording, suggest which house is most likely to be closer to a train station. So I could write house H is most likely to be closer to a train station as it has the higher price per meter squared, and the fact that the product moment correlation coefficient is negative indicates that houses closer to the station tend to have higher prices per meter squared.